All right, time for another explainer here. This is gonna be kind of another long one here. I'm gonna do a full start to finish on making the files and sending files, everything for making a shoebox cabinet. This is just gonna be a small panel, but it's gonna be for the type of signs that the outer face will shoebox fit over a backer and then be attached that way. So, but this one just happens to be a small panel for something going on here. So I was just sent this earlier. This is per the request of one of my coworkers. What's up, Arturo? He wanted to kind of know how to do it. So unfortunately for him, he triggered a video. And so now I'm gonna, you know, lay it all out. So he might just quit. I don't know. I hope he doesn't quit, but you know, after watching this, he might just give up. So anyway, so I'm gonna go start to finish on this. And then, yeah, just like I say, pop some popcorn, grab your Snuggie, and let's get after it. So usually what happens is somebody I request to get the file sent over at a full size 1:1, and then I go ahead and copy those dimensions and things over to my workspace that has everything set up, my nudge and all that. So like I said, I'm going to do start to finish, and I'm going to go over using, you know, my macros and everything to get things done. So that brings up the point that I want to stress. So I'm going to go a little bit of rant here and just a precautionary, you know, hey. So if you want to do this, if somebody wants to get into this, then this isn't just adding somebody to the repertoire of sending files. If you want to get into this, then you'll essentially be working with me, under me, in my department, as far as sending things to both route and fab. Now, when I say fab, I mean kind of route as well, because we are so dependent on route that I kind of have always looked at fab and route together in a way. I really rely upon route to back up fab. And so to have a good solid cohesion between those two. So the whole reason for this is I look out for my buddy. I look out for the homie next to me. And so I want to make sure that everything I send to route is everything that I need to help back them up, to give them everything they need to you know, have a successful mission on that, and then be able to push those things through to fab. So if I'm doing my job correctly, then route does their job correctly, and then fab does their job correctly. And then of course that trickles down to install and everything. So if you want to get into this, it isn't just a matter of sending a DXF file to route. It's about making sure that even install, that what you're doing now is going to benefit install and what you're sending. So, and the other thing is that, well, I've been now doing the macros for 15 years, but sending files to route, it has been a good solid 10 years. And so now, you know, it is standard operating procedure. It's SOP, that this is the way things are going to be sent. And it isn't just, well, that's just the way AJ does it because he's got his cool macros. No, it's become the way that route expects files to be sent. And it's the way fab expects files to be sent. So that way they have everything they need to win. It's one thing to be sending, you know, acrylic rectangles. And I'm not diminishing anybody or anything, any departments, but it's one thing to send acrylic rectangles to a department and say, here's 50 acrylic rectangles. Good luck. Fine. Fine. You don't need a lot of documentation. It's just, here they are. You sand them, you paint them. With fabrication, there's so many moving parts that all those moving parts are a huge opportunity for failure. And the other side of that is that, you know, in the hip hop industry, you know, we push weight. We push and weight in fab, which means there's a lot of money. When you push things through and you send a DXF, you're sending sometimes tens of thousands of dollars of just raw product. And if you do something wrong in these methods, when you're just sending files to route and they're going to like fold it up and bend it and route it, there's no free lunch. There's never is. So this is a highly tuned, highly strung way of doing this, where if you do it right, we can finish a sign in minutes and it could be out to paint, and the amount of profit's ridiculous. But the no free lunch is that it has to be done properly the very first time, because there's no editing, there's no hacking, there's no modifying something you sent incorrectly. And then, you know, it's like, oh, well, we can just cut it and paste it and we can chop in a piece. And well, the Frankensteining, first of all, will be a horrible product, but sometimes it's just not you just can't do it. And then it means that you basically have to reroute the piece. You have to correct it and reroute. And everything you routed goes to recycle, you know? So it's high stakes. And so I'm not trying to scare you. I'm not trying to blow myself up. It has nothing to do with ego. It's just that this side, if there's a lot going on, and you got to understand why you're sending something, you know? So in that respect, that's why it's important to be able to do it exactly how I do it. Now, a few little things you tweak, fine. But how you send a file is just as important as the actual DXF file being correct, okay? So you might send the DXF file and be perfect, like excellent. But how you sent it to route, they might be going, well, I don't know, and then they route it wrong. So you sent it correctly, but the information you sent along was incorrect, or you didn't send it as a whole. And then an assumption was made, rule 3, and then so it fails at the router. And then let's say it makes it through there. But if you don't pass information properly along to Fab, which they are required, you know, they're looking to me for the information. You know, forget having to make videos, which has really been a helpful process. You don't have to make a video, but you got to make sure that the information, so let's say you make the file correct. Excellent. It gets routed correctly. Excellent. But then fabrication doesn't get what they need as far as like, you know, this was supposed to be on the outside. This part was supposed to be facing up, and then they weld it or do something wrong. Well, they either have to try to hack that piece out that they just did wrong, or even then it could be a loss. And then you got to start over all the way to the beginning. Once you add in all those labor hours, forget it. Like I said, we are pushing weight in the fabrication route area. If you want to get into this where you're sending metal, you got to make sure it's done properly. It's not just a question of, oh, I put some route scribes, you know, bend scribes, and then blah, blah, blah. If it doesn't fit, it doesn't fit. There's no fixing it. It's got to be thrown to recycle, and, you know, everyone's crying. It's, you know, a very sad day. And then, you know, they got to reroute it. And it kills morale, number one. I don't like doing it. I'm not saying I'm perfect, but I'm usually pretty lucky because I've been doing this long enough. But also, if you use the macros, if you use my macros, a lot of what the macros do is force you. There's no other way to do it wrong because the macro is a computer. It just computes. It does computing. It's what it does. So trust in the system, but it might take a learning curve. This isn't one thing where I'm just going to be like, yeah, this is how you do it. And you go, okay, cool. And then you just sort of do it your way. It can't be. It's got to be the way that we are now accustomed to. And I do apologize if I make it look easy and, you know, everyone thinks they can do it. I am all for teaching people, but it's going to be a learning curve. The fact that you know how to use Corel, that's amazing. You're already up on it. The fact that you can export a DXF, right. But you got to make sure it's all done in a way that fabrication is expecting that, you know, it's expecting that pitch. You know, a catcher gets to know his pitchers. So, you know, when a catcher says, yo, send me this, the pitcher sends it. The catcher already knows it's on its way, you know. But instead, you get some new guy up on the, you know, the pitcher's mound, and he's sending fly ball. He's sending, you know, crazy knuckleballs everywhere. The catcher's going to be like, I don't know what's going on. You know, I'm out. So, you know, whatever analogy you want to use, that's basically the importance of making sure that you follow along and do exactly the way, you know, 99.9%, 99.44% of the way I do it. That way everything flows. And like I said, this is big money. Now, you know, doing this little panel, okay, you know, but imagine something like Eagle Mountain. Imagine something like anything that we do where, you know, we're literally tens of thousands of dollars just in raw aluminum. And if things are wrong, entire sheets are the wrong size or something, you didn't move holes, the amount of money it would take to fix or, you know, anything, you just got to be on point with this stuff. So I'm going to make this video. I'm still going to talk to you, like, you know, we'll work it over in person, IRL and all that. But so anyway, so that's that. Let's get into it. Let's get after it. Rant over. So I'm going to bring in the file. You're going to, you don't have to send the full size to yourself if you're the guy making the file, making the actual design. But I'm bringing this in. So what you're going to want to do first and foremost, and I understand that the design guys and ladies and theys, You guys are all working from 8.5 by 11. And then what you guys are doing is changing your page size to kind of accommodate the actual, drawing. But if you're going to be doing what I do, you're going to want to work with a standardized page. So I would maybe up here and custom make a page just for this kind of layout. Or if you're there working on your unit there, so what you can do is take your Mr. Goodbar, and your Mr. Goodbar automatically changes your page size. So I like an 800X by a 600Y, and now you've got your page. And so now this is like your workshop. So every day you show up to work, you don't change the shape of your building. You don't change the dimensions of your building. You work within the constraints of that. So I like to have a nice big page. I know also a lot of people like to work off the page in design. They'll put it over here if they don't need it. I don't do that because there's certain macros that won't respond because something's off a page, or this is just clutter. So keep everything in your, this is basically your workshop here. Keep everything on your page. So I'm just going to leave this as the OG. So what I'm going to do is I'm going to go ahead and break this. I'm going to copy this and I'm going to paste it into a new page. And you can see mine pops up where, again, work in your space. If I try to work in your space on this workspace, you can see your nudge is at 0.008 because you're insane. I don't know what's going on. But I come work in my place. I've got everything set up. My nudge is at 1 inch. My micro nudge is at 16th. You'll see how important that is. And I also have my macro nudge at 12 inches. So I have everything set up. So get whatever you're doing into your workspace. So I'm going to paste this in. And then, so using my exporter, I got Patent Design Studio, and we're just going to call this the Shoebox. Save as. So it's going to automatically name it. We're set. Boom. We're all good. So I can go ahead and close the original because I'm going to keep the original here on the back page. So this is my document of record. This is my chain of evidence. So now what I'm going to do is I'm going to go forward with this, and I'm going to create a new page where we're going to work from. Now, this one isn't so important because it's obviously just a rectangle that's 8 by 82. I don't need so much of this with just this. I mean, you could go to somebody and just be like, hey, make me a panel that's 82 by 8 by 1. But again, it's the chain of evidence. It's later on, Route and Fab are going to want the full deal. You can't just go to fabrication and Route and just on the way by, on your way to lunch, be like, hey, make me a panel, blah, blah, blah. I know a lot of shops can do that, but it's going to get dropped. So even if it's quote unquote in your mind, very simple, think for other people. Think that even though it's simple to you, there's 100 things going on in the back shop. So keep it within the parameters and put it through channels. That way it gets done in a way that everyone's used to. So I'm not going to copy paste this forward. I'm going to start here. But what I am going to do, and which is nice, is that you actually did a great job. This is 82 by 8. So all I got to do is I take my rectangular here, right? You got the rectangular up here, as you do. You hit X, you select it, you hit X. That gives me 82 there. And then you hit Y, then that loads this. So now I don't have to type because we all know I am in open warfare against my keyboard. I don't want to type. That's for animals. So I hit 0 degrees here, and there we go. So now I have my starter. Now I like to start up here and work down. So this is the OG size. I'm going to work from there. Now, what we want to do is we want to make a profile, a side profile. That is what we're actually going to build it from. So I'm going to go up here and you see the little C channel thing here. This is my extruder machine, right? So we're going to take the extruder machine and it's going to make a side profile of the channel. So I'm going to take this guy here, and so it's A, B, and C. So B is the middle part. A and C are the legs. So I'm going to take this, I'm going to hit Y, so it's going to load 8. And then I know, I'm going to have to type, yeah. I know that this is going to be 1 inch deep, right? And I know that the thickness is 090. We are using 090 material. It defaults to that. Don't worry about any of this stuff for right now, or if ever, whatever. And then you're just going to hit make extrusion. So now we have a 8 by 1 extrusion. Now what I like to do is I like to make my face red. So this is why I have these. If I click red, it makes it a red outline and it removes any fill automatically. That guy Phil, he's shady. And then what I like to do is do a temporary rectangle for the inner backer. So now this would be impossible to fit onto. So when it comes to making a shoebox, just like the word, the name implies, when you buy a pair of shoes, the lid fits over the main box. So in signs, you have a panel, which is the lid, the red, is going to slide over the backer piece. And the backer piece can either be mounted to a wall, or it could be mounted to another sign as a panel, you know, for a tenant sign or something like that. So what we need to do is massage. So this is the first part of knowing what you're doing, knowing why you're doing it, and making these decisions based on having built these in real life. So again, you're at a bit of a disadvantage if you haven't installed and you haven't actually fabricated one of these and then had the frustration of making it too tight and you can't slide it on and you're grinding and all that. So you got to make a decision. So let's go ahead and make this blue. Well, let's make it purple just to start for temporary. So when this goes to be installed, you'll have zero clearance on the top, obviously because of gravity, right? And then this is obviously way too tight because you're literally not going to have a zero clearance thing slide on. Also remember that aluminum does not slide against itself at all. It galls up, it gets sticky, it's like gummy. So if aluminum tries to slide on aluminum, it will gum up and just stick and it won't move. So you got to have plenty of clearance. So now here's where you have to ask yourself. I have basically three different basically, what do you call it? Like clearances. The first one is a true shoebox friction fit. This is going to be the tightest you can make something. So again, if you go here to Mr. Goodbar, we're going to shrink this thing 0.01, right? Right here, up and down on the top and the bottom. So this is the minimum you can get away with. And even this sometimes is a little too tight. But this is a 0.01 on the top, and this is a 0.01 on the bottom. So if you want this backer to be on the wall and you want to slide this thing on to where you almost have to use your fist to kind of bump it on, then this is what you want. 0.01 on the top, 0.01 on the bottom. And then you can friction fit it on. If you're doing any sort of kind of fabrication like that, generally I always bake in 0.01 for clearance on these things. And sometimes that's not enough. It just depends on the bending. It depends on the weather. I don't know, anything. So there's that. Or what you want to do is I'm going to go ahead and put this back here. Dun, 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 dun. There you go. Oh, why did it move? There you go. All right, so now the other one you can do a minimum if you're going to have a little more room to slide is to leave the top, again, zero clearance because of gravity, but the bottom, you can go a 16th. So I got 0.625 there, and I'm going to shrink it on the bottom. That's about the minimum you want to do because also you have to take into account how long this is, and the break is going to be weird, and how this thing is going to be on the wall. When you go to install this and you go to slide this on, even a 16th might actually be kind of tight. So it just depends. The whole difference is like, yeah, if this is going to be inside somewhere and it's going to be attached to a nice flat drywall, wall, which even, at 82 inches, you're going to be spanning some studs. Drywall is not completely flat. It's actually very wavy. So you got to keep that in mind as well. So you want to bake in as much sloppiness as you can without being just entirely too sloppy. So what I like to do for the most part is bake in an 09 on the bottom. So I'm going to go ahead and just move that up an 09, and we're going to take it off the bottom. And then this is basically what I use for almost everything. So if I do this is an 09 nugget right here. So you can see I have 09 spacing between the backer on the bottom. And especially over something that's 82 inches across, you'll have plenty of room for kind of sloppiness. And then also even the bigger one. So like, let's say this is one of those cabezon cabinets. So you've got something that's 10 feet by 5 feet and it's got push throughs and heavy. Generally 090 is enough. This is about the maximum I go because your screws are going to go through here and this is going to get pulled down and it's going to get, you know, sucked up against, and this is going to get sucked up. So 0.9, it seems to be about the magic number. But again, if you don't want hardware on the top and bottom and you want this to be friction fit, then you go ahead and leave it at full. And then you're just going to take 0.01 off the bottom of each side. And that's going to be a pretty tight friction fit that the guys will almost have to bump it on there with their fist and it should stay. You don't want to do a friction fit if it's outdoors or if it's going to see any kind of heavy weather. I wouldn't trust it. You're going to have to put some hardware top and bottom in order to make it fit, you know, make it stay. But again, it's up to you. And this is where knowing these things really helps. So let's get back to building this out. So I'm going to go ahead and use this as a model to build the side piece, and then the side piece will help me build the backer on this side. So I still got my extruder machine here, but what I'm going to do is I'm going to go ahead and do the full 0.9. So let's go ahead and take the full 0.9 off the bottom. So there's our clearance. And now you have to also clearance the front, because we want this, let's say this is your wall or whatever, right? We want the face to bonk fully against the wall, bonk. But we don't want this to conflict, right? So when we bring this up, this is zero clearance right here. And in a real life, this is going to be sticking out a little more, a little less, whatever. So we also need to clearance it this way. What I'll do is oftentimes I'll just do a 1/16. And if we take it off the face, so you got the little arrow here, there you go. So now we have plenty of clearance on the front right here. So that way the backer piece won't interfere with the face. And that allows the face to snug all the way up against the backer here. Now, sometimes you don't want the face to go all the way against the wall. Maybe you want it to float a tiny bit off. There's a 1/16. Then what you'll do is make the backer be the one that it bottoms against and set that depth by using the backer as the depth setter, right? So then, you know, so it's just all about whatever, you know, again, you got to know what's going on. You got to think it through. But this side profile here, this side profile helps you figure that out. This is hugely important to lay this out, because then you can just extrapolate these sizes across the face, and then you helps you build the side and the bottom and the top. So this is what we're doing. So like I said, should have popped some popcorn. And yes, there will be a test later if you want to do this. So let's go ahead and do our Y. So we're going to build extrusion here. So again, we're going to do the vertical here is the B section. So we're going to grab that. And so you can see where 7.73 is what we have now. And then we're going to grab the X across here, which is 8.4750. And then we're going to have X again. We got 090. We're going to make an extrusion. There we go. So we can move that out of the way. And I like to make the backers blue. So the inside of a shoebox, I like to make blue. That way we can differentiate what we got. So I'm going to go ahead and slide this in. And again, snap to is super important. Keep your snap to on, because we want everything to fit together like Legos. So now we have our shoebox with clearance, and we have clearance on the front, and we have the actual dimensions that we need for cooking this up. So now if we're going to do hardware across this top and bottom, is where we can use this to decide how we want that hardware. Now, in order to give maximum flexibility, I like to do a hardware with a roval. So we'll find the center of the 1" across here, and you can see where this will be a number 10 screw with the roval slotted to allow for maximum flexibility to fit this way, the face, right? So we'll go ahead and do that, and I'm going to duplicate, and then using rectangular down here, we have snugs and we have edgy. Edgy will put the center of the first one to the middle, the center to the top of the second one. Snuggy takes the bottom of this and nests it to the top of this. So this is edge to edge, and then this one is center to edge. So super helpful, super handy. I use this all the time. That's why I got, you know, the rectangular stays in the corner here. So we're good to go. So now this shows where you want your screws. I moved this down a little bit just to kind of keep it more compact. So this is going to show where this screw lands on the backer. Super important. And it also shows where it lands on the face. Super important. And so now what we want to do is we want to make a representation on the front view of this piece of 090 on its edge. And we want to make a representation of the whole panel this way. And we want to make a representation of the backer. So this is where we start to build down. We start to extrapolate this. But you can see how important laying this out was. So now what we're going to do is we're going to use rectangular. And I'm going to load this back up 82 by 8. And now, since, like I said, we want to have a representation of this bar, and we want a representation of this bar, and that is what these letters here are for. So you have LR, which is left and right. You have top and bottom, left, top, right. And then you have the thicknesses of these. You have 09, 062. These are the usual suspects. So if I were to just hit 0 right now, I will get a rectangle that's 82 by 8, right? There we go. That's what we have here. But I want a representation of the 09 on the top and the bottom. So I hit TB for top and bottom. And now I get the same rectangle, but I get the representation of the 090 on the top and the bottom. And I'm going to go ahead and make that red because that is the face. And I'm going to line it up with this, and I'm going to bring it down. And I'm going to go ahead and do it by nudge so everything stays aligned. So I'm going to go 1, 2, 3. That's 3 feet down, but it doesn't matter. And I'm going to go ahead and copy this, and I'm going to bring this down 3. So now we're working. So now you can see where this is the side view in red of the face in red. And this is the front view of your 090, and that's this 090 right here. Now we can go ahead and make the backer. And again, now we can just grab this because we have it represented. You grab Y, 7.73. And you can go ahead and use the 82 because we can do the math here in a second. So go ahead and do this. Go ahead and hit 0. And we're going to go ahead and nestle that right up to the top because that is where this one is, right? Nestled up, 0 clearance. Go ahead and hit C for center. Now we need to shrink this one in enough for our clearance. So you can see where we have our 090. This is a piece of 090 right here. So we have our 090 clearance, right, for the bottom, but we need to add that to the sides. So what we're going to do is I'm going to make a vertical nugget, and this vertical nugget is going to represent the end of the cabinet. So this is the piece we're going to weld in later to the red, okay? Just for that, what I'm going to do is I'm going to go ahead and make those red outline. There you go. So you can see the red outline on that. And so obviously there's a conflict here because this is way too long. So let's go down here onto Mr. Goodbar, and we're going to go ahead and shrink that by 09. Okay, now we have zero clearance. So the backer now in blue can just barely fit. So now I'm going to go ahead and shrink it one more time. And now we have 09 across the bottom, and we have an 09 clearance on the sides, okay? And I'm going to go ahead and copy these, and I'm going to send these down to this end, okay? So that represents our welded in edge. And so now this is a good representation of our backer. So now I'm going to go ahead and copy the X. See, now we've moved it to 81.64. So now what we're going to do is I'm going to do another top and bottom, boom. But this is now our backer. I'm going to hit blue, and now I have our blue backer. And I'm going to go ahead and temporarily, really quickly group this. And that way I can just send it and match it. And then I'm going to send that to the back. And then I'm going to go ahead and get rid of the duplicate piece I had. And now we're good. And so now we have the representation of the front of a backer that fits with 09 clearance on the sides and the bottom with 0 on the top because gravity, it's going to sit there. Which means, you know, you have to be careful that because now your backer is not justified to the center of the face. You have this sort of offset for the backer. So you always have to keep that in mind, and it's important to do that. Okay, so now we have our backer and we have our side. So now what you want to do is you want to adjust the backer. You have to clearance for welds. So here again comes in where it's helpful to have welded before and having built these things to know what you got to clearance. So I'm going to go ahead and take this guy here and we're going to make a purple weld. You know what? We're going to do magenta because you know who you are. And I'm going to go ahead and take this And we're going to go ahead and get rid of one of these, and we're going to bring this over here, right, into the center. And we're going to go ahead and cusp each of these, and we're going to straighten this one, and we're going to straighten this one. And so now we have a quarter circle. This is a representation of what a weld would be in the corner. So you can see our conflict already, where if you were to slide this in, you would not have, it would be conflicted. So what I like to do in order to make this relatively simple is I will take my 09 nugget here, and this is a representation of this bar here, and I will move it a full inch. There you go. Then I will take the same nugget and I will move this down an inch. And what we're doing is we're mitering this corner. So essentially now the backer is going to go to this nugget, and it's going to go across here, and then it's going to continue here. And what we're going to do is we're going to chop this corner off and dog ear it basically, so that way we have plenty of clearance for weld. Keep in mind that I like to keep at least a 1 inch no fly. 3/4 is pushing it, but you're going to have heat affection. It's going to be warped. You're going to have little boogers and little snots and stuff all over, little pieces of metal. Also, this is a non-illuminated one, but if this were illuminated, then we would also have sealant. We'd have caulk here. It'd be built up. It could get in the way of this here. So you want to make sure that you clearance these corners, basically clip them in order to clearance for welds. So having had this little formula here all set up, I'm just going to duplicate and flip, and I'm going to bring this down, and since I know it was 1 inch, I move it up. And so that's my corner there. And then what I can do is grab these, right? And then duplicate, move it down. And then since I don't need these, and I don't need that, I can go ahead and then use this as an alignment tool, put that in the corner. There's 1 inch. So now we have basically this is going to be the extent of this guy. If you want, you can ungroup this and actually bring this back a little bit like that. And you can bring this back like that. And maybe bring this down, line that up with that, and then you can just erase that. So if you want to do that for yourself so you can remember that you're clipping this corner, that's fine. You can do that as well. We don't need the weld anymore. So there's that. We got that set up. We're getting the backer dialed in. So now we need to build a top view and a bottom view because we have our side view, our profile, we have our elevation this way. So we need to do basically a plan view of this. So what I do is I copy this, I take it up a little bit, and then I'm going to lay it on its side 90. So Mr. Goodbar, I have a 90 button. Boop, there you go. That's the sound it makes. Boop. So now we have our 90 this way, and it's going to match. Essentially, we're matching the 1 inch tall here, but we can go ahead and move it up out of the way. So it's kind of, it's out of the way. So again, so what I'm going to do is I'm going to grab the X dimension, which is 82. And then I'm going to grab the Y dimension of this, which is 1. And then I'm going to make a rectangle, just like that. And I'm going to go ahead and use that node as alignment like that. But I'm going to go ahead and make it to the bottom of this. There we go. I'm going to make it red because red is for the face. And then I'm going to go ahead, since I know that this is in the center of this, right? We know that. So I'm going to go ahead and make an inline for references for later. I'll show you what that's for. And because it's an inline, you want to name it. So you hit this blue button there, go for naming, and now it's a blue, sky blue inline. So now you have this is going to be your flange here with an alignment reference point. But we're going to go ahead and make the blue backer as well. So what I'll do is I'll just grab this Y, and that's 84750. And then I'm going to grab the X from this blue. And I'm going to load it. And then I'm going to go ahead and make that one. And then I'm going to make it blue. And I'm going to align it to the top of the red. There you go. Now what I'm going to do is I'm just going to pilfer this one, duplicate, and then I'm just going to drag it up here. And so now this one has its own inline for reference. So the blue one has its own inline, and then the red one has its own inline. And so now what I can do is just grab this, duplicate, and I can send it to the center. And here's where we have our holes. So our holes, our screw holes, are going to be automatically, they're already lined up because so this flange is just going to get welded to this face. This is why it's important to take these steps and just sort of build it out flesh it out from components. And then from there, you're set. It's got to be 100%, success. What you can do here is you can grab this guy and drag it to where it matches here. And then you can also grab your inline. We'll send them to the back. There it is. We'll make that size. And we will match this one to this. And we'll match this one to this. There you go. So now we have a hole in the center. And then what we can do is maybe go that many. So how many did I go? So 36 plus 2. So I go 1, 2, 3, 12-inch macro plus 2. Okay. So there's 38. This might be a little too far. Now this brings up another thing. If you're going to do this, you got to understand UL. You got to be read into the program. This doesn't need to be UL. That's fine. But if you're going to do this, UL, the maximum distance between fasteners is 24 inches. You have to have a fastener on center every 24 inches or less. So as the material gets thinner and thinner, the distance between fasteners gets narrower and shorter and shorter and shorter, down to the point where super thin metals require a fastener like every 6 inches. It's ridiculous. So you got to keep that in mind. Now this is going to be more for design. Is 38 too much? I think so. So I would just go ahead and hit plus. Go ahead and have 4 of these. Now this is where rectangular comes in handy. I have horizontal center, horizontal spacing, vertical center, vertical spacing. These 4 buttons. So you don't have to go doing shortcuts and whatnot. You don't have to touch your keyboard. You just hit that button. So now we are horizontally spaced at 25-ish. That's pretty good. I think that's a good representation. You're within the backer here. So then what I like to do is I'll take this, duplicate that, and then I will line it to the top of this. That way it matches, so you kind of get a representation. Excuse me. And then we'll do that to the bottom. There you go. So this is a top and a bottom representation. Since the bottom is going to be the same as the top, we just go like that, duplicate, and then we just flip it, just mirror it. And so that can be the bottom. There's your top, there's your side. So we're close. And so now we have this all fleshed out. So now we need to think of the backer. We need to think of how it's going to go on the wall. So here is where knowing what hardware, install favors. This is where it's helpful to have installed a couple times. It's 100%. You got to know what substrate this is being installed to. So is this going against a cinder block wall? Is this going against studs? Is it going onto another sign? If this is going onto the face of another sign that's 09, you're going to have a completely different type of layout than, let's say, this is going onto a brick wall or something. So you got to know that to know what size holes you're going to use, the spacing of the holes, how you lay it out. Again, it's about helping out your homies. So you want to set up install with the high, highest chance of success. Help your guys that are downrange, help your homies. So what I like to do is I pretty much have a minimum of a 1/4 inch hole when it comes to putting these installing this stuff, because minimum, if they're going to be putting this on a drywall covered, studs interior, then they're going to be basically using number 10 stuff. Like if they're going to be using a toggle bolt, then it's going to be a 3/16 toggle bolt, a number 10. They might be using drywall screws or gold screws into studs. Those are 3/16. So a 1/4 inch hole is good for that. You can always drill a hole out. So if it's a little too small, install can just grab one of their drill bits, and it's a little pain in the butt, but they got it. It's fine. What you can't do, other than putting washers onto a screw, is make it smaller. You don't want too much slop, obviously. That being said, if this is going onto a stucco exterior wall or a brick wall, then they're going to favor 1/4 inch blue tapcons, aka blue screws. Masonry screws, which are 1/4 inch diameter, So then you're going to want to step this up to a 5/16 for exterior. Now that might not even be enough, because even though you're on an exterior wall and you have a pattern, let's say, you know, trying to hit a screw hole exactly on a stucco wall or a brick wall, these are going to wander. So sometimes, you know, a quarter inch blue screw into a 5/16 hole is not enough. So that's when I will do maybe a 3/8 when it comes to that, because they can always, you know, then put a washer on that, but that gives them the maximum amount of, you know, leeway. Other times you might actually need to do a slot. You might need to do like a roval where you hit slot machine here, and you might be having to do something that gives them maximum adjustability. So you would then, you know, place these in a way that, you know, you have left to right a maximum amount of, you know, lining up. So that, you know, again, there's no way to just say, this is what we do. You got to kind of know, you got to kind of think it through, and you have to put yourself in their shoes. Even though they're kind of small for me because I have big feet, but you got to put yourself into their shoes and see what's best for them. So right now for this, I'm thinking it's going to be interior, whatever. We're going to do 1/4 inch holes just for the sake of argument. And then, so I'm going to go ahead and hit over here on my launch pad. You have your circles over here. So I'm going to go ahead and hit 1/4. It's going to put a 1/4 inch hole up there. We're good to go. So I'm going to go ahead and just center this. Now here's where, again, it's important to work with the backer or the face, but we are off center now. You know, we're justified here. So you need to make sure you're working with either the face or the backer when you're working with centers. So if I select the backer, obviously, and I hit center, but then I hit, you know, if I center it to the face, then you can see where, you know, it's moved. So make sure you're working with the backer when you're centering things up, and you're not accidentally selecting the face. So now what we do, since this is in the center, on something like this, I'm going to go ahead and do the side view as well. Let's go and put that in the midpoint there. Obviously, this is going to be too wide to have something just dead center. This is too much flap. So you're going to need top and bottom. Now, if this were a little bit further in, and this was only like 5 inches, let's say, something like this, then maybe obviously you could get away with something maybe more down the middle, or you would zigzag it. You know, you do something like this as you go down the middle. If this thing was, you know, a little bit skinnier, but at 8 inches, it's pretty. You can get away with kind of spreading these out completely, you know, top and bottom. So that being said, I start in the center. I duplicate. I go 1, 2, 3 inches. And I go 1, 2, 3 inches. This is why, again, it's very helpful to have your nudge just set to 1 inch. Just do it. It's easier that way, because a lot of this stuff, 1 inch, perfect. So now these are going to be 6 inches on center. Now what I'll do is I'll go ahead and group this. And then another thing is making sure that your holes aren't too close to the edge, because sometimes if they have to do a toggle, the hole they have to create for that toggle is pretty big. So you want to make sure that that hole for the toggle doesn't kind of peek out over here. So you definitely want to make sure that these aren't too close. A good rule of thumb, see there's an inch about. So I like to try to keep at least an inch away from the edge. So I'm going to duplicate this and send this over here. Another thing to think of is, again, imagine you're the one using the frap, the impact wrench or whatever. So when you're putting your tool in there, you want to make sure you got enough clearance. Maybe you're using a socket, you know, maybe they're having to use a socket or something. So you want to make sure that socket has clearance up against the wall here. So again, think it through. What would install do? How can they do, you know, what can you do to help them succeed and to have a successful mission? So, but I like this layout here. It's pretty good. So now here comes your decisions as well. How far apart do you put it? So let's go ahead and scoot 1, 2, 3 plus 2. And let's go ahead and scoot 1, 2, 3 plus 2. There's 38. Because again, my macro nudge is 12 inches. So, so now this is going to be a little too far apart. You probably could get away with this, but again, you're looking at 38 inches or whatever it was. That could be enough depending on what you know it's going on. But I like to keep, and again, fasteners is one thing, but structurally speaking, I don't like to go farther than 18 inches apart, or closer, I say, 18 inches apart. It just depends, but I don't like to go more than 24 inches usually. So let's go ahead and add 2 more. And I'm going to grab all 3 of these, and I'm going to grab this one, and I'm going to grab this one, and I'm going to do horizontal center. And then I'm going to have my layout like that. So let's go ahead and interrogate this and see what we got. We have basically 19 on center, which is about right. Now there's also another benefit to this. Now you could get rid of this, and you could go probably get away with on something like this. It's not heavy. It's probably interior. You could probably get away with having 4. We're back to 25 on center. This could work, but what would help install, and it's not that big a deal for them to drill a few more holes, is sometimes on something like this, is give them a center hole on center. That way they can help align on center. And what they'll do is they'll go ahead and shoot a screw here, and then go ahead and level it, and then shoot a screw here and shoot a screw here. So sometimes it's better to add a little extra. 2 more holes isn't going to kill anybody. Also, install can then make the choice where maybe they'll put these 2 in, and then they'll put like 1 here, and they'll maybe put 1 here, and then put 2 here. You know, they can also make good judgment calls. When it comes to shoebox, if you're talking a bigger shoebox, if you're talking actually like a cabezon sign where you've got a lot of weight hanging off of it, I will always default to a lot more mounting. It's better to have more screws into the, studs and screws into the wall than less, because it'll stay up there better. The other thing is to make sure that, especially when it comes time to doing these bigger signs that have more weight, when it comes to engineering and physics, you want to keep your mounting screws as close as you can to these screws, because the path that has to travel means stress put into the framing. So the whole idea is the stress that's coming from the wind, from the earth, trying to blow this face off of here, then gets transferred to this screw, and then that screw transfers that stress to the backer, which then transfers it to the mounting screw, which then is connected to the knee bone, which then connects it to the ground. So the faster you can get those stresses from this screw to the ground through the backer, with the shortest distance of the backer having to put up with the stress, is better. Now, granted, this thing doesn't weigh anything. It's fine. We're not worried about that so much. So obviously having these screws be this far, we've got 6 inches. So the stress of this screw going across the backer to this screw is not that big a deal. But when I am less worried about how something looks and I'm building something for strength, then I will work backwards, where I will put the mounting first, right? Then I will align these screws right dead with that, and I will make sure I have at least this many mounting screws that will correspond and get that stress directly to the building as fast as possible. That way in here, this isn't really doing much work, because you'll have, your backer is mounted to your wall, and this is the mounting point, and it's this, the physics, the engineering, and then the stress is going to run right through there. Boom, we got it done. Versus having this screw out here in the middle, and it's going to have to transfer load across, and this is going to get, broken and bent or whatever. So anyway, I digress, but that's what you're going to want to do. But for this, we're sort of trying to make it look good, so it's more form over function. So let's go ahead and just realign these, and realign that, and we can realign that with that. There we go. Okay, so now we have our mounting layout. I'm going to go ahead and leave it like this. Again, install can decide to maybe not even put screws here. Whatever, they can do what they do. So there's one more step. We're just about there. All we got to do now is go ahead and make a reference of what's up. What direction does this get mounted? And again, something like this is like, oh, you're oversimplifying. You're making it too easy. You're spending too much time doing this. Well, again, think about it. When fabrication gets this, they won't have seen anything about this. You know all about it. It's fresh in your mind. But anytime somebody else gets a job, it's like a truck hitting them from the side. It just comes out of nowhere. Here's the job. Boom, get on it. And they're like, okay, whatever. So yes, we both know, or all of us here know, that this is completely symmetrical. It's 8 by 82. It can be flipped. It can be rotated. It can be, but install won't know that. They won't know that maybe, they'll be like, well, maybe this needs to install a certain way. And so ambiguity is the enemy, and it causes you to have to do step 3, the 3 agreement. Number 3 is make assumptions. So make it to where there's no assumptions. Even though technically it can be installed either way, make it clear. So you're just going to select this. You're going to hit your launch pad. You're going to hit your arrow up, and it's going to put a reference kiss arrow right in the center. This reference kiss takes 12 seconds to route. It's no big deal. It takes pennies. It's nothing. So it's better to have it there. That way, when install shows up, they put the pattern up or whatever, it's clear. And they don't know that it's symmetrical, but nor do they care. They just know that this is up. Make it simple for them. Help your homies succeed. Same thing for install or for fabrication. Also, if this goes to the vinyl shop, if there's no up or down, they just assume and they'll go ahead and put the vinyl. But if you put an arrow, it'll help them out. They'll be like, okay, cool, this is up, fine. So just that little bit helps everybody win. Okay, so we're on our way to making, so now it's just time to make this. So let's do it. So let's go ahead, and now what we're gonna do is we're gonna iterate down. We're just gonna make parts down as we go. So we leave this. This is like, we can return to this. This is where we're making things from. So go ahead and copy it or duplicate it, bring it down a certain amount of nudge. And I like to duplicate it again because we're gonna make the backer. So one of these is the face and one of these is the backer. So let's go ahead and make the backer first. I usually make it up top. I don't know why, but that's how I do it. So now what we're gonna do is just eliminate what we don't need. So anything that's in red is not the backer. So we're gonna get rid of the face. And get rid of all those. And then that just leaves us with the backer. So now we know that this backer is actually flipped the other way. So what we want to do is mirror this. So that way this blue is lined up like that. That's the flange. See how the flange is going to stick up? So we want to make sure that this is the proper direction, right? The shorty side goes to the face. So this is properly aligned. And we can go ahead and just get rid of that. And we can just duplicate this forward and flip it and smack it, make it good. So we're going to go there. Now what we can do is get rid of these extra mounting holes. We don't need these because these were just for layout. We can go ahead and click that. You can just go ahead and click that to that. So there's our backer. It has, come to life there. And so we can just do the opposite here. We can get rid of everything that doesn't have to do with the face, which also includes these mounting holes. We don't need these. We can go ahead and leave the arrow though. We can get rid of all this. We can get rid of this because that has nothing to do with us. Same thing here. And we can also get rid of basically the reference things there. And then I'm going to say we can get rid of the mounting holes there. And now we can get rid of the inline for that. We can just get rid of everything that has to do with backer there. Now these are already set up. These are correct. So we can go ahead and, oh, I don't want you. Again, snap to. There you go. So there's our face. There's our backer. So let's go ahead and flesh them out. So what I do is I'm just going to grab this backer here, and then on your Mr. Goodbar, you're going to hit Make Thru Shape, Make TS right in the middle here. You're going to hit that, and it's going to name it, and it's going to fill it with a 10% gray, which is aluminum. And then what you're going to do is grab this one, and you're going to grab this one, and it's also going to make a Thru Shape behind it. So you can see where there's this piece here, and there's this piece here, right? Now you're going to weld these together by hitting weld right here. We're done. So there's your backer, right? Now you're going to clip the corner. So all you got to do is grab the node, and because you have your nudge set for 1 inch, there you go. There's your corner clipped. There we go. So here's your backer, getting close. Now, what you could do here is go ahead and clip this completely. And then what you can do is, because the reason why you leave this chamfered like this is because for light leaks, and if this was illuminated, there's a good chance that some of the copy would go right to the edge. So you can't clip the backer this much if this was illuminated generally. So you would want the backer to go all the way over here, right? And then you would close it off for light leaks and things like that. But because this sign is not going to be illuminated, we might be able to just get away with shortening this and not going down this road. So let's just go ahead and clip it completely there. And that will give us the max clearance we need, since this is not going to be illuminated. Otherwise, you're worried about light leaks and you do need to close this end off. But let's go ahead and do that. So we're good there. And let's go ahead and fill this guy up. Now this one is simple because it's all just one piece. So you select the whole thing, you check your measurements, 82 by 10, and you hit make through shape. Now you have your panel. So we're good to go there, and we're good to go there. Now let's get our bend scribes going, but we got to make sure we do it correctly. So what we're going to do is select the inner rectangle, and then you're going to hit Magic Machine right here. You're going to bring up this button that brings up Magic Box Machine, and it brings it up to the scribe line creators. You're going to go ahead and hit this button. That's going to create a scribe line here, and you're going to hit this button, and it's going to create a scribe line there. Make sure that you do that because it's named with the scribe lines. Don't just draw one. Don't try to make it by hand. Use this because it's named, and it'll be in the proper position for this. So there you go. Now, here's another issue that you have to learn if you're going to do this, is that when you bend and create a C channel like this, the part you clamp will grow 1/16 of an inch. That's just how it is. So you need to build that in and make sure you are compensating for that. That is why we have this inline here, because we need to make sure that we shift everything that 1/16 of an inch. As you recall, we don't have a 1/16 to lose. So we need to make sure that we adjust our fire that 1/16. So now we need to grab this backer, right? We got the gray backer here, and we are going to bring this down 1/16, and that's why I have my micro nudge to 1/16. That's why it's my bread and butter. I hit Control, and I bring it down 1/16. I bring this one down 1/16, and I bring this one up 1/16, and I make this one 1/16. There we go. So now when fabrication clamps this and bends it, this will regrow to that point, and then that will then become this true size. Otherwise, it would grow 1/16 and it won't fit. Well, this would be right at, but anyway, you have to allow for that. Now, the other thing you have to allow for is the position of this will then shift 1/16 unless you account for it. So you have to account for the hardware moving as well. So now we're going to shift these back 1/16, just like that. We're going to select these 1/16. We're going to select these up 1/16. And we're going to select these 1/16. Now, that is where this thing comes good. Now I can verify before I send that this has moved 1/16. So I can look, I see that that's good. I see my bend scribes are in place. So I'm stoked. I've got my reference arrow here, and I've got my mounting holes. This thing is pretty much set to run, to go. Now, again, think of your homies. When this is bent and it's on the wall, this could potentially be something a guy could scrape against, rip his shirt, cause him to bleed out. We don't want that. So I'm going to go ahead and chamfer or radius these. Now I know that natively you can use the fillet docker, But again, you have to type, and it really sucks. I don't like it. So I went ahead and made my own macro, as I do, that just has my usual suspects for radius. So I'm going to go ahead and radius this for 1/8. And I'm going to go ahead and radius this 1/8. And I'm going to radius these ones for 1/8 as well. You know these ones. That way, when this is on the wall and it's installed, it'll be somewhat safe. It won't be so sharp. Just got to kind of think of your homies, try to hook them up. So now this piece is essentially ready to go. So I'm going to save. The backer's good to go. If you want, you can hit your little good to go right here, and that puts a little green dot. This is my way of knowing I'm done here. I like it. So now let's go to the face. We're going to do the same thing. We're going to select the main box, the main shape, you know, this outline, and we're going to put our magic box machine just like that. We're going to put our bend scribes. Now, here's where you can make the decision as the designer. Do we just leave the 1/16 of an inch there? So when this thing grows a 1/16 of an inch, is that actually a good thing? I'll tell you what, most of the time, I leave the 1/16. I don't mess with it. Because what that does is that it allows just a little more room here. And if it doesn't hurt anybody, and if it doesn't make it, you know, that much of a difference, I don't adjust the fire to this. I go ahead and let it grow a 1/16, and there's no harm, no foul. If anything, it actually just helps things. But if it is priority that this thing stays to 1 inch exact, then you have to do what you just did on the backer. You have to bring this in a 1/16, and you have to bring this in a 1/16, and you have to bring this one, and then you have to bring this one. Okay. And then you will have to adjust your mounting hardware as well. So you bring those down a 1/16, and you bring these up a 1/16. And so now we are adjusted, and when the guys clamp and bend, it will be the true size. But again, when it comes to the face, now like I said, the backer we have to adjust because it literally won't fit. But the face has that luxury of, if all it's going to do is grow a 1/16, then leave it. If that's the case, you do not have to shift these. If you're going to leave this at a 1/16, then you don't need to shift the hardware because you want this to remain a 1/2 inch. If you were to move this but leave this, then now we're a 1/16 off. This is not good, right? So, but let's just keep it like we have it, where we want the true shape. So let's bring this down. There we go. So let's save it. Now, before we send this out into files, we have one more thing to do. We have to make the end caps. We have to weld the end caps to the sides here, but we have to create those. Now, you could theoretically just go like this and say, okay, it's 9725 or whatever, and that's the piece that I need to send, right? And there you go. You know, that's the end piece that needs to get welded in. But through exhaustive R&D over the years, there's a little bit of a magic sauce you got to have. So it isn't just as forward direct as just, you know, drawing a rectangle and making it fit. So that's where you go to Magic Box Machine. I actually have end caps. See on the bottom here? This down here is where you make the end caps for these types of boxes. So what you're going to do is you're going to grab the OG, right? You're going to grab the OG rectangle, and that's going to give you your Y. And then you're going to pick, see, I have usual suspects here. I have a 1/4 or 3/4 inch, 1 inch, 1.5 inches, 2 and 3. But then you can also, you know, choose your own custom. And so what this is this matches the width of this. So if your box is going to be 1 inch deep, then you're going to push 1. So you're going to select the rectangle, right? And you're going to hit 1, and it's going to automatically produce the proper size dialed in secret sauce end cap, okay? And it's going to put it on both ends. There's 1 and there's 2. Now, the problem is, it's not a problem. I usually leave what I just said. I usually leave this one and I let it grow a 1/16. So this end cap is actually set for if this thing grows a 1/16. But because we brought this down a 16th, you need to make a through shape. So hit MT, make TS, and you need to shrink it by a 16th as well. So if you're going to adjust this fire here, then you need to adjust the end cap, because the end cap comes out from the machine here ready for leaving it native, just leaving it crazy. But if you're going to trim, you got to trim. So we're going to go ahead and put this over here. Oops, I grabbed the wrong one. Come on now. There you go. Okay, so now we have our end caps. And again, fabrication, they know what's up now. We don't need to do this, but this is what the icon guy's for. If you hit your icons, you can hit spool gun, and then that will let fabrication know that indeed you need to weld that. But, you know, fabrication, no. They know what's up. But again, it's about passing on information. All right, so I think we're looking good. We got our bend scribes, we have it adjusted. We have our end caps, they're adjusted. We have our reference, everything. So we're good to go. So I would put a stamp on that too, because I've audited it, I've made it look good. So we have our backer, we have our front, good to go. So now it's time to make files. And this is where it's very important that you do it the way that I do it, but the way that we do it through this process. So that way fabrication and route both have all the tools they need, and it comes the way that they expect it to. So let's get rid of everything here. We don't need this, we don't need that. We really don't even need rectangular anymore. So thank you for your service. So what we're gonna do now is we're going to hit the hello, my name is right here. Up here, you're gonna hit your N, or on your go time, you have it here, your N, and that's gonna bring it up. So let's make pages for what we have. Now we really only need one page because this is all gonna fit on one sheet, that's fine. So you're gonna go to auto list here, name page in the middle. We're gonna hit 090, and then let's go ahead and call this shoebox panel, shoebox parts, let's do that. There you go. Now you're gonna hit make new page, and that created a page over here, all ready to go. Probably we can just set them aside. So now we can go ahead and copy paste this onto this page. And again, just bring everything with, because you can clean this up here. Do not clean the parts here. What I mean by that is don't worry about getting rid of your inlines. Don't worry about getting rid of any of this. You're going to do that here. So leave it just as it is. That way you will always have a record of what's going on. So go ahead and ungroup everything. Get it all set. And then let's go ahead and get rid of the stuff by hand that's easy to get. So we can get rid of this. We can get rid of our icon. We can get rid of that. We can get rid of that. And we can get rid of that. And what I like to do is make sure that everything's laid out in such a way that it makes sense for fabrication, because what they're going to do is they're going to print this page that you're going to make, and it is going to be a sort of a reference for inventory. So when they go to start working on this, they know what to look for. So they'll look for these little end pieces, and they'll look for this piece, and they'll look for this piece. So make sure that it's laid out in such a way that it makes sense. And then what you're going to do is go ahead and put it towards the middle of the page, just like that, and save. Good to go. And so now we're going to lay out our layers. So we're going to hit layers machine. That's going to give you this. And it's going to hit info words. It's going to give you this. And then we will be using send it, right? So let's go ahead and set up our layers first. So you're going to hit info words. You're going to get throughs and shapes, 5/32 bit. You're going to go ahead and do a 3/16. You're going to do a quarter, and you're going to do a whatevers, as in let them figure it out. We do have a reference kiss on center, 5/32 bit, on center shape. We do have bend scribes. So here's your bend scribes, 090, 5/32, 050 bit, or 045 depth. Get a little confirmation. And I don't think we have anything else. We don't have backed up. We don't have stud mount. So we're good to go. So thank you, Layers Machine. Don't need you anymore. Now, info words. What's our material? 090. There you go. So what I like to do is make sure it's sort of in a proportion that's good, not too big, not too small, because we will be printing this out. And so we don't want the whole page to be taken up by the words. We want to make sure the words are just a small part of what we're printing out. That way we're not wasting space. Okay, so we're good there. Save. Now what we do is clean up all the junk. This is where you bring in send it. You push send it, and what it's going to do is help you work with layers very easily, and it's going to help you get rid of all the cruft, all the junk that's on here. So this is a list of all of our layers. Everything so far right now is on layer 1, minus this. This is already on info words, so you don't have to worry about it. So what I like to do is you're going to select everything, make sure everything is ungrouped, and then you're going to hit Super Scraper. This little unassuming button right here does a lot. What it's going to do is go through everything's names, and it's going to pick the crud that we don't need. So you're going to hit Super Scraper. It has selected the stuff we don't need, and what you're going to do is just nudge that down and then audit it. Don't just trust that it did it correctly. You're going to verify. So what you want to see is your inlines. You know, that's junk. We don't need that. We don't need these nuggets. We don't need these things. We don't need any of this. And then what you're going to do is come up here and verify that nothing is missing of import. So all this looks good. Everything's looking good. You've got your two little end pieces here. So now you can just delete this. Good to go. Let's save it. Now we need to clean up our mounting holes. If your mounting holes, right, we have the slot, but we also have the other one. We can't send it like this. If we send it like this, this is bad juju. So we know that the clearance is on the face. So if we select everything, just select everything up here. And if you hit 165 right here, it's going to automatically select the 165s because they are named, and you can just hit delete. Now what I want to do is I want to fill these just so that they're filled and they're easy to see. I like this blue. It's one of my favorites. I like that. So now we have our clearance holes. They're laid out. We have our bend scribes. The face is ready to go. Now we do the opposite. This right here, if you look down in the corner, it's called a 2-2 roval. Well, if I hit this and I hit 2-2 roval, I have a button for it. Look at there. It's selected them. You pull them out of the way, you hit delete, and then you confirm that all you have left are 165s. So now you have your screws ready to receive the face. And now you have your cleaned up, you know, parts here. Now what you want to do is do a quick Doop Checker. You're going to check for duplicates. So you hit Doop Checker right here. Boop. And there you go. Doop Checker will be coming to the website soon. You'll be able to buy Doop Checker. You know, check in at dieselbuilt.com. That'll be coming soon. So what you're going to do is select everything, and you're going to hit position and size, and it looks like there's no duplicates. Sweet. If there were duplicates, it would move it over and you'd be able to find it. So, but we're good to go. So you can close him. Now it's time to make files. So now we have our Patent Studio, Design Studio exporter here. It's already saved. So now since we have the page is named, the page becomes the file name. So you come down here and you see where it says select. What it does is it selects everything and it loads the file name from the page name right here. Then you're going to hit export DXF. It's going to run Doop Checker one more time. Oh, we got to get rid of the empty layer. So forgot that. So you can see where everything now has something on it. Oh, you know what? Oh, getting a little ahead of myself here. We have to put everything onto the proper layers. I forgot about that. Yeah, this is real time, folks. So even mistakes. So what we're going to do is hit bend scribe. That's going to grab the 4 bend scribes. You send that to layer. You're going to grab the reference kisses. You're going to send those to reference kiss, hide that. You're going to go ahead and grab everything that is basically set for a 5/32 bit. That's going to go on to 5/32, hide that. You're going to grab the next size, which is a 3/16 bit. That's those Those go onto the 3/16 bit layer. And then the rest of this is going to go on whatever bit route wants to use. Now we can hit delete. Now that got rid of all that. We make that all visible. Now we can export. So you can see where my exporter actually helped me out there. I got ahead of myself, but my program would not allow me to go any further because I was about to play myself. So now we can hit export. It looks like there's no duplicates. And now we have ourselves a DXF file. That's ready to send. Now the other thing we need to do is we're going to go ahead and preserve this entire file as a PDF so that Fab can reference it. So make sure nothing is selected. You grab name here. And what that does is it renames the whole thing, you know, off of the actual document. And you're going to go ahead and hit reference PDF. And now what this did is it just automatically made a PDF with the name and everything all ready to go. And so now this preserves the entire CDR as a PDF for Fab to reference. So they don't need to open CorelDRAW. So we're good to go there. And now what we need to do is get a print ready version of this that only has the route file stuff that is ready to print on an 11/17. So now what we do is we save this, make sure it's saved, and we are now going to create a print ready version. So from exporter here, make sure that it's named Shoebox panel, and you hit print prep. What this does is this saves the CDR out to a new CDR that's called layers print with a very long row of underscores. What that does is it makes it very easy for me to see this particular file. You can see that all I got to do is look for underscores, and I quickly know which one of these are prints. So these are print ready files versus my normal files. So that's all that is a visual reminder. So now we're working with a completely different CDR. This is not our production CDR. So when you do this, it brings up these two things. It brings up printer ready, player one ready, and it brings up quality control checklist. So what we're going to do is we want to get rid of this because this has nothing to do with what we want. And we want to get rid of this. So page 2 and page 3 have to go. What we're doing is we're making print ready versions of our DXF files. So we can print these on an 11/17. Then what happens is Fabrication uses this as a inventory checklist. So they grab that 11/17 piece of paper and they check off that they have these two little pieces and they have these two pieces and everything's routed properly. So what you're going to do is you're going to trim this whole CDR down, and we are going to go from page 2 to page 3. That's going to trim these pages, and it's only going to leave page 1. There you go. And what it did is it also resized this. It's not to scale, doesn't matter, but it resized it to an 11/17 sheet of paper. Next, you're going to hit quality control checklist, and it's going to put this little checklist up here that, you know, sales likes it, paint likes it. You know, we're not using this yet, but maybe one of these days we will, whatever. So now we're ready to break this out into another PDF. So once you've done this, you get rid of this, you get rid of this. Now all you have to do is hit print PDF, not reference PDF, but print PDF. And this now breaks this out into a PDF that is just this page, see? And so now but Fabrication is going to be looking for this. So now when you go to send this to the route department and when you send it to Fab, Fab will want to see this reference PDF, right? And Fab will also want to have this in their email. So when you send the email, you're going to send this and you're going to send this. And just for ha-has, because this doesn't take up hardly any space, you know, this thing is only 388 kilobytes, and this one is only 405 kilobytes. I put these into route jobs as well with the DXF. So when I go to the server and I put the DXF into route jobs, I also put these two as well. So that way they have all the tools they need. You know, maybe route doesn't look at it, they don't care, fine. But later on, you never know. It could be handy. But these two for sure get put on the email to Fab. Fab needs these. And that's what I was talking about at the beginning. If you're going to do this, this is how we send metal parts through route to Fab. And this is what it takes to do what I do. So again, this was way longer than it should have been because I was explaining every step. I could have done this in a quarter of the time. Don't get discouraged if this is what you want to do. It just takes reps, and I will work with you to try to, to get you on board. But again, we play with big numbers. We play with live ammo, and we can't be sending things incorrectly because it's very expensive. So again, if anyone wants to do what I do, that's what it takes. Appreciate you sticking through. Again, I appreciate all the new people. Got a bunch of new subscribers. Appreciate you. It's great. So, but I'm also dieselbuilt.com. You'll see it down in the description below. I have my website up, and I'm going to start breaking out some macros. They'll be for sale. Some of the macros you see. So bear with me. I'm just figuring it all out. So, but anyway, so as usual, if you have any questions, hit me up.
Check the